Ready when you are.
Ready for me?
Yep.
All right. Let me share my screen. Hopefully the right one. I'll put you over here. All right. Let me know if you cannot see that. I will assume otherwise that you can see it. All right, so let me start the clock. I always stay on the clock. So this is a React crash course for Sitecore Dinosaurs. I'm going to talk a little bit about what a Sitecore Dinosaur is in a minute, but I think the folks on this call seem to have a good idea. So for those who don't know me, my name is Brandon Bruno. I have a website. I have a Twitter handle based out of Atlanta, Georgia. So if you're ever up this way, please stop by. I promise I'll buy you a beer. Hopefully we can return to symposiums next year. Hopefully I can go. We can do the same there. I am a Sitecore MVP this year. This will be my last year because as of this year, I actually joined Sitecore. I've been working with Sitecore for about 10 years, so this feels awkward to say now because I'm pretty sure I'm the youngest dinosaur in the room at this point. I feel like everyone here in this room has probably been around longer than me, but that's okay. 2017, I started my blog and community effort, Sitecore Spark, a couple of modules out there and a few other things, and of course, speaking and whatnot. So who's this presentation for? Well, this presentation is really for people who see, they don't necessarily see a future for their backend skills. That's kind of a broad statement, but it's in more generic terms. It's for someone who doesn't see the exact future coming for that utilizes the skills they've been comfortable with for the last 5, 6, 7, 10 years, whatever. My personal journey here is that I joined Sitecore and I immediately set off to learn Next.js because Sitecore is going to be making a big deal about that over the next 12 months. It's one of the paths forward for architecting on Sitecore. And I got to about the second page of the Next.js documentation when I saw this block of code. And I saw this block of code. And I thought, okay, this is JavaScript, no big deal. I'm going to go ahead and just read through this because I do know JavaScript. I'm not too worried about it. Except that I started going through this and I realized I didn't really know what the heck most of this was. Import, class, static. I mean, I'm familiar with some of these concepts from other languages, but as far as JavaScript goes, this was new to me. And then I got to this line down here where in the render method, and I saw this return div, and I'm like, I'm pretty sure you can't do that in JavaScript. I'm pretty sure that should be a string right there. Like, what? This isn't right. And then I saw this export. So I'm like, okay, I came to the conclusion after diving into Next.js for all of 5 minutes that I really was behind the times here. I had no idea what was going on in modern JavaScript and React. So ultimately, I decided that this talk is for the traditional backend developer. Like me, I've been working with Sitecore MVC for a little better part of 10 years now. And I do feel a little threatened. Preferably, this talk is for those who have absolutely no React experience. If you have a little bit of experience, great, awesome. I will encourage you to set me straight if you hear me misspeak. More importantly, this talk is really for those people who want to be kind of well-educated and well-rounded. You're certainly not going to be coming out an expert on the other side of this talk. That's not the point here. The goal of this talk is to make sure that you get some exposure to some more modern JavaScript concepts, and you get just enough exposure to React that you feel comfortable going forward with the framework and have a few other starting points to learn from. So if you're a dinosaur, that implies that you're probably old and rusty and out of sync with the world, and maybe feeling a little threatened by extinction. On the other hand, being a dinosaur means you might be at the top of your game as well. You know, you might be at the top of the food chain. You might be a solutions architect. You might be a lead developer. You know, life is pretty good. You can crank out an MVC site with the best of them. Some of us, though, do suffer from imposter syndrome pretty bad, and this is the actual dinosaur we actually are today. Not a pleasant feeling. Nonetheless, yeah, I'll leave it up there for a second. It's true. Yeah, thank you. More the dog than the costume, really. Regardless, here's the future we got coming, and us dinosaurs are down here, right? So It's really not that bleak. I don't want you to think that you're suddenly going to be obsolete in 12 months. Obviously, there are some there's plenty of back-end work out there, and there's definitely rendering host options with the MVC rendering host that Sitecore's been talking about. So the goal of this talk, let's become more well-rounded developers and learn a little bit of what our front-end brothers and sisters have been doing this whole time. So here's our agenda. Just three pieces. I'm going to try to cover this whole thing in 45 minutes, so I'm going to go quick. If you have any questions that are absolutely pressing, feel free to blurt them out and stop me. Otherwise, I'll try to gather them in chat and we can talk at the end. So first, we're going to cover modernizing JavaScript. We're going to talk a little bit then about React 101, just the basics of the library. And then we'll spend the rest of the time looking at actual code samples. So there's not a lot of theory here. There's a lot of code, a lot of samples, a lot of working functional pieces that we can kind of go through and play with. That's my cue to drink. And let's modernize our JavaScript. Now, if you've been around long enough to be considered a dinosaur, I'm assuming you've been working on the web for a very long time. I have to make the assumption that you know the Ecmascript 3 version of JavaScript. And just to give you a visual, that's the version of JavaScript that's been around since about 1999. And it's the version of JavaScript that built basically Web 2.0. So all of the 2000s, Web 2.0, Gmail, Ajax, the jQuery was a big thing in this time. This is the version of JavaScript that really built the modern web today. And then somewhere around 2009 and again in 2015, the community and development JavaScript developers decided we needed to do better. So of course we created ES5 and ES6, and that's kind of where we are today. There are a few other versions, but they don't matter. JavaScript has again reached an annual. Ecmascript has released an annual update cadence, and JavaScript is trying to keep pace. But things work in some browsers, they don't work in others. In general, we're just going to focus on the higher level concepts here of ES5 and ES6 that will make working with React all the more pleasant. All right, so let's do this. This is going to go quick. First up, variable scoping. Anyone that's ever written JavaScript in the last 25 years probably has used the var keyword for declaring a variable. That's great, it works. There's a few issues with scoping, but no big deal. Introduced with ES5, and I might get these versions wrong, so bear with me while I pause on that. ES5 introduced the let keyword. This basically means that a variable will be scoped only to its local lexical block and nowhere else. And then constants were introduced, and just like other languages, this basically means a variable is not mutable, can't be changed. Template literals. This is let's take two variables, first name, last name. Traditionally, in JavaScript, like many other languages, you might use string concatenation to build these things together, to bring them together, right? String plus variable plus string plus variable. It works. It's not always pretty to read. Template literals basically give us a way using a new string notation. So instead of using single or double quotes, and let me get my pointer out here. Instead of using single or double quotes, we use the backtick character to define a string, and this allows us to then use tokens for our variables. Using this token format, $ curly braces, we can drop our variables directly into the string, and in this case, we would get that output. We can also evaluate expressions in template literals. So in this case, I can do a little bit of math here, and it works all the same. Arrow functions, something I would definitely spend an entire presentation talking about. So here's the basic version that you need to know. Here's a typical function in JavaScript. It has the function keyword, an identifier, some parameters, and a body, right? That looks like a function in just about any programming language I've ever used, which might be a good thing or bad thing, depending on how many languages that you think I should be using at this point in my career. Arrow functions really just strips out some of the ceremony. So we have parameters on the left, we have our fat arrow, and then we have our function body on the right. Arrow functions are really about removing some of the ceremony and simplifying the syntax for declaring and using functions. To make this usable, we would just take this function, assign it to a variable, and then we can use it like a function, the way we'd expect to use a function anywhere else. You can also write without any parameters, so you can just use empty parens and then our function body. Where I'm going with this is that, as you'll see later on, because functions are first-class citizens in JavaScript, they can be passed around like variables as parameters to other functions. This is a very useful way of writing functions with very short notation in places where you know where you might need them. Promises. This is a whole nother talk, so I'm going to give you, again, the 10,000-foot view here. This is about the only slide that has some graphics on it. So promises in JavaScript are essentially the idea that the promise that something will execute, then something else will execute following that. So in this case, a promise will always execute some logic, and then it will either resolve with success state or it will be rejected with a failure state. The key thing to keep in mind here is that this follow-up execution is always asynchronous. And when we get to the code samples, it'll be pretty obvious. This next line might be a little controversial, but promises are guaranteed to a degree. So when you do when you execute this first block of logic, this first method, this first function, whatever, you will resolve it or you will reject it, pending a few catastrophic situations. So here's the short version then. This is an actual promise. You may not write this very often, but this is what a promise actually looks like. So promise in JavaScript is a top-level object. You new it up, and then you pass it a function as a parameter. So here's where our arrow syntax comes into play. So we're actually writing a function here. We have two parameters, resolve and reject. So we're going to go off and do some work. We don't know how much that work it's going to be. We don't know how long it's going to take, and we really don't care. All we care about is, did the work complete successfully or did it not complete successfully? If it succeeded, we're going to resolve this promise, and we're going to succeed. If we failed for any reason, we're going to reject this promise. Here's where some of the magic comes into play, because promises use a concept called chaining, where we can continue to execute some logic with subsequent methods attached directly to that promise. So in this case, the resolve method implicitly maps to then, which is a reserved method for promises. And then it also, the reject will map to a catch method. So in this case, this promise, once resolved, will execute the function passed into the then method down here. The actual name for this is a thenable, which is such a weird name, I'm not even going to say it again. And then the catch will typically handle errors. The reality of it is, and this is just based on my experience working with JavaScript, most of the time you end up working with promises on the consuming end. You're not really writing a promise yourself, but you're going to be, writing code that looks something like this. You're going to get some data from a server, for example, then you're going to do something with it, then you'll do something with that result, and if anything bombs out during that process, you will catch an exception. And handle the exception, I should say. You'll catch the whatever you need to catch, an error, an exception, whatever comes back from that, and you'll handle it. We're going to come back to this in a moment. So I know I'm going through this really fast, so if this doesn't make sense, we're going to see some examples that will illustrate some of the power of promises. So window.fetch, this one doesn't really directly relate to React. Super obviously, but the React docs recommend using window.fetch for Ajax functionality, so I definitely wanted to include it here. Window.fetch, if you're used to writing your own XML HTTP request objects, or if you're used to using jQuery's Ajax method, this is the all-encompassing browser-native way of fetching resources going forward. Browser support's pretty good nowadays, so there's no issues there. And quite simply, it's give me a resource and let me fill out some parameters. There's a whole bunch of parameters here. I'm not going to go over them in detail, but I did highlight cores because that's a big deal nowadays. Fetch itself is a promise. So when a fetch executes, the browser goes off and fetches a resource, and when that resource grab is complete and it loads what it needs to, it fires off the success or resolves the promise, which calls our then method, right? We get back a response object. This response object has a whole bunch of stuff on it, one of which is a status. So like a good developer, we're going to check our status, make sure we don't have any errors. Our response is coming back, and this response object has some helper methods. I'm not going to go through them in detail, but the point of these methods is to help us parse our response type. So if we're expecting to get some JSON back, there's a JSON helper method that will spit out a JSON object of that data. There's also a text method, a blob method, a form data, an array buffer, I think, is another one. So it can help us massage the data we get back and give us something that's native to what we're expecting. So in this case, I'm expecting to get some JSON, so I call the JSON helper, and that itself returns a promise. So I'm going to go ahead after that succeeds, log that object to the console so I can inspect it. And then, of course, if that original fetch method was to bomb out for any reason or that promise is rejected, we need to have that catch method on there to gracefully handle an error message. So let's go back to promises real quick, because we're going to talk about a slightly newer syntax. This is much newer. We're talking about ES5 and ES6. I believe this is actually part of ES7 or 9, whatever, 7 or 8, 7, 8, 9, somewhere in there. I honestly don't know the version off the top of my head. Async and Await is a way of handling promises with a little cleaner syntax. So I have an async function here, which indicates to the interpreter that this is now going to return a promise. Let's go ahead and implement that method we just saw. So let's go ahead and fetch a resource. When that comes back, we're going to parse the response and get the JSON back. Oops, hold on here. Come here. And drop that there. So we're going to get the JSON back and stuff that in the data. Now we have a JSON object of our response, and we're going to return that. And if anything goes wrong, like a good developer, we're going to try and catch the possible errors and exceptions. And then we're going to utilize that method, get data, and then go off and do something with it. Now, what you're looking at here is the exact same, essentially the exact same logic that you saw here. So I'm going to put those up on the screen back to back. Now, the async and await syntax essentially helps us write promises as if it was procedural code. So instead of having to do all of this chaining where we have window.fetch.then.catch and we have a .json.then, we can write code that looks more like procedural code where we can use traditional try catches and we can await things to happen. So just to talk through this code really fast, every time the interpreter gets to a method tagged await, the interpreter will actually stop, wait for that execution to complete, so in this case the fetch, then it will continue on. It will then await for this JSON method to execute, then it will continue on. By tagging this function as async, the interpreter knows it doesn't have to wait in this entire method to finish. If there's other work to be done, it will continue on the execution of whatever happened when get data was called. Promises are pretty thick. I don't expect you to necessarily wrap your head around the entire concept here, but it is similar to asynchronous programming in a few other languages. But you will definitely see, once you get into React down and dirty, you will see a lot of folks using either the chainable methods of then and catch, or you'll probably see them starting to write async and await quite a bit. So wanted to make sure we cover that. All right, modules. JavaScript does support modularization, and it's a complete mess. That's the short version. So here's what a module might look like. Let's say we have person.js. We have two methods, say hello, say goodbye, and we can export those. Bottom of our file, we actually physically write export, and then we export one method and another method. Somewhere else, we can import those methods, or one, or none, whatever we need, or everything in the file. There's all kinds of syntax to play with here. We can import that, and then we can use it. Obviously, we want to use modules to break down logic for large programs in ways that allow us to utilize only what we need when we need it. That's really the point of modules in most languages, especially JavaScript. The real problem with JavaScript here is that there's 4 different versions of modules right now in JavaScript. And it's a bit of a mess. What I showed you here is the Ecmascript module variation, which is the newest flavor. This is supported in browsers, but it's not necessarily supported by React natively. So things like CommonJS, Require.js solve some of the other issues, and there's different tools that you'll use in the front end, different tools you use in the back end. It's just important to know that JavaScript does support modules, and it's really important to know that React components themselves break down across modules really, really well. So it's very common to create a React component as a module and then import that where it's needed elsewhere. JavaScript does support classes, just like other languages, for encapsulation purposes mostly. And in JavaScript, a class has a constructor. This is unique in JavaScript in that the constructor exists. There's only one per class. And that constructor is implicitly called when the class is instantiated. So here we pass in some variables, we assign it to some local variables, and we also have a method to provide some functionality. And we would use this just like we would in C#, pretty close to it. We can new up an object and have our constructor fire and use whatever methods and fields and properties we need to on our class. Classes do support inheritance, so we have, for example, a teacher that extends that person class we just saw. We have our own constructor that does something slightly different. Important takeaway here is there's a super keyword that allows us to instantiate the person class and call its constructor. So that's what you're seeing right here. So as this extended class, first thing you should do is call that super method and make sure you're instantiating all the right places. Instantiating all the right constructors. All right, that was the crazy crash course version of JavaScript. Thanks for staying with me. So let's talk about what React is, and then we'll talk a little bit about why React and what brought me to this point, why I'm even talking to you about it. I'm guilty of screwing this up left and right for the last 7, 8 years. React is a library. React is a library. It is not a framework. A framework implies a lot more than what a library provides. So React is a library for building components with JavaScript, just components. To put it another way, React helps you define borders around what is a component, or it gives you the guardrails for thinking in terms of components. If you were to sit down with a blank HTML file or a blank Notepad++ file, let's say, and I told you, develop a HTML component system or a JavaScript component system, where would you even begin, right? There are concerns. There's common concerns like when you think about components, what do you have to think about? You have to think about data management. You have to think about state management. You have to think about event handling. You have to think about updating components, how to provide interactivity. React basically provides most of these pieces for you through convention. I think the people who don't like React are the people who just don't like doing it the React way, and that's okay. There's other libraries and frameworks out there for you to play with and other ways of doing things. It's been around for a while. Like I said, it's been around for about 8 years. It's been called a couple different things as far as I can tell, but nowadays it's just React. And it is maintained. It was originally created and maintained by Facebook. They've opened it to the developer community, and that implies everything that comes along with it, including all the politics of having thousands of people with voices all contributing at once. So, but it is actively maintained. It's well maintained for that matter. Why React? Well, I'm being the MVC backend developer that I've been writing code since the 90s. I just don't like jumping on the newest shiny thing. I like to watch something mature before I dive into it and spend my precious time learning it. So that's where React is. React is stable. It's widely supported. It's very well documented. You have no problem finding help and documentation. So I appreciate that. The component architecture problems that React is trying to solve for is actually a common problem, as we all know, on the front end. And Vue, Angular, Astro, Svelte, there's all kinds of frameworks and libraries out there that are trying to solve very similar problems. So if you learn React and you learn some of the basic concepts React's trying to solve for, I think you can have a slight head start in some of these other frameworks. I'm not saying you can learn React and then go out and start writing Vue, but you'll be able to recognize some of the challenges and some of the solutions being proposed. And this is the sneaky one. I wanted to learn Next.js. Sitecore is big on Next.js. It's going to be a thing. Next.js is a framework for React, so that's really what it is. I wanted to learn Next.js. I have to learn React. There's no way around it. So that's a big reason for this. And finally, I found myself building more complex, even as a backend developer, I found myself building more complex, multi-component interfaces on the front end. And I've been doing it with jQuery up until about 6 months ago. So it's time to stop that. And I've actually found React is doing a very good job. It does a very good job of breaking down my components and my interfaces and my apps. Now, to be fair to the other side of the coin, why not React? I haven't had to deal with this yet because I haven't written a sufficiently complex application myself. I've worked on teams where we did, but it's not terribly fast. I'm not saying it's slow and not useful, but React has somewhat of a reputation of being slow for certain types of applications and for certain scales of applications. So that's something to keep in mind. It does require Fed experience for complex projects. So if you're going to be writing React on a larger team and you're actually compiling on the back end and you're pushing out, Node is necessary. And once you introduce Node, things just get ugly. And oh my gosh, it's nuts. I recommend having some decent Fed experience if you're going to have a sufficiently complex project. Finally, then, if you're going to create a content-driven site, if you're largely creating a content-driven site and you're intent on delivering that directly to the client, React is not the answer. You absolutely do not do that. You don't send down a blank HTML file and then toss in a bunch of JavaScript on there and have your client render that site. There's lots of reasons for performance and weight and page speeds, but really what the business cares about is SEO. Browsers can render fine, but search engines can't necessarily crawl all that content, so you have to deal with those issues. All right, so let's get into the meat and potatoes then. So this is all code. We're going to go through a bunch of slides showing some concepts, and then at the end of this, I'm going to open up an actual React application, and we'll just kind of look at it, play with it, and you guys can ask questions at that point, and we'll wrap up. So here's the hello world example. Here's my HTML file. You'll notice that we have, and I'm sorry, my Teams keeps flaking out over here, so I'm just going to come back. There we go. Here's an HTML file. We have 3 files. We have React.development and React DOM, and we have Babel. We need to render our app somewhere, and that's what this div is for. You'll see that pattern throughout this entire presentation, the rest of these slides. Now look at the script here. We're going to write some JavaScript. You'll notice that what the type is, it's not JavaScript. We do have to transpile this, and we're doing this in the browser. We do have to transpile this code that I'm about to write because it's not pure JavaScript. It's what's called JSX. It's a JavaScript extension. It's unique to React, and it's a syntax that helps us mix HTML and JavaScript in line. And this was the hardest thing for me to get over when I learned React because it goes against how I learned JavaScript. But I think it's okay. So this is it. This is our hello world example. We have React DOM.render. This method is the entry point for any React application to the DOM. So render tells React what to render and where to render it to. So in this case, we have an element or content, which is an H1. And we have, whoops, oh, spoiler alert. And then we have our container or our target, our destination. Where do we render this content to? So in this case, it renders up to our root div right here. And that's the output. Pretty simple. So JSX. JSX is hard to ignore because it looks so weird. Again, like I said, this is the thing I had the most trouble with. This is JSX. This is an extension to JavaScript proposed by React. And the idea is that you can write markup or what looks like markup, like this H1 tag, in line with JavaScript. So this is a line of JavaScript written as JSX. So I have a variable declaration here. I have an H1 tag. I have some attributes. I have my content, and I have my closing tag and my semicolon, right? This is JavaScript. And then I can pass that element to the render method, React DOM.render, and it will do what you expect. It renders that content. You can do all this without using JSX. Here's the JavaScript version of the exact same thing. So there is a method called React.createElement. It takes 3 parameters. It takes the tag we want to render, an object of all the different attributes and their values that we want to output, and then it takes our content. All right. The code on the top of this, the JSX up here, actually gets compiled or transpiled down to this JavaScript here. You can write raw JavaScript and never write JSX, but as you'll see in later examples, you lose some of the benefits of syntax, the clean syntax provided by JSX. So just know that these two things are equivalent, If JSX really bothers you, you don't have to use it, but I think there's going to be a strong argument by the end of this presentation for it. So I go ahead and render both of those out, and that's the result I would see in my browser. React has expressions. Quite simply, this is just how you get values into your content. So I have my dog is named Lizzie. I have react-dom.render. I have curly braces to denote an expression here, and that allows me to fill in some content. Boom, just like that. All right, so React is all about components. So we're going to talk about components here. Finally, right? There's two types of components in React. There's functional components and there's class-based components. So let's look at functional components first. In React, you can actually just write a function and you can return some JSX. So I have return h1 in my content. This works as you would expect. I call my react-dom.render method and I pass in for my element, I can give it my function and it will spit out what you would expect. Pretty simple. Now, React components become immensely more useful once we start talking about class-based components and writing them as classes. So let's go ahead and write a class called animal, and you'll notice that it extends react.component. React.component on a ES6 class, this provides all the functionality you're about to see going forward. So everything else here, properties, state, events, everything exists because React.component brings in all the necessary pieces for this to work. So we had to extend that. Every React component class also must have a render methods or a render function somewhere in it. So this is what react-dom.render looks for when it actually outputs a component to the page, to the DOM. And this example, this is basically the class equivalent to what you just saw in the function. I'm going to go ahead and render out this component. You'll notice the syntax here is a very tag-like syntax. And we're going to expand upon this over the next couple of slides. But I pass in animal, I pass an animal, and React looks for the render method, and it spits that out right there in our browser. All right, we're going to talk about properties and state. Properties first. So components would be a lot more useful if we could get data into them, right? So let's take a person. Let's create a person class. Let's have our render method there. There's our content. And React.component provides something called properties. And properties allow us to pass data into a component. So we can pass data into a component and use it just like you see here. This.props.firstname. First name is passed in. So I'm going to go ahead and render this out. So here's react-dom.render. Here's my person, and I can pass in what looks like attributes as my properties. So in this case, last name equals Brandon. Now, there's all kinds of things wrong here. You'll notice that there's actually a mismatch, right? I'm passing in last name, but I'm trying to reference first name up here. That's okay. React doesn't care. It just won't render something that's not on that props object. Not a problem. We'll play with that a little bit more in the next couple slides. So just to review, properties are for getting content into a component. State is for managing values inside of a component. As where properties are intended to be brought into a component and not mutated, they're actually read-only. State allows you to store values inside of a component and update them over the lifecycle of an entire component. So let's start with a component called building. Let's have our class constructor where we are going to set some values up. And we're going to reference this.state. So this.state, and this, of course, in this case, references the building class. This.state handles all of the variables that we want to track throughout the lifetime and life cycle of this component. So we have floors for, and we have a price, which actually comes in through the props. So I'm going to put my render method out that I'm going to spit out this values of the state variables. And then down here, I'm going to render the building component, and I'm going to pass in a price, which then works its way down into my state. That's the value we'd get, or the content we'd get in our browser. You can update state a couple different ways. Yes, you can assign directly to state. So if I really wanted to, I could say this.state.floors equals whatever and update that value, or this.state.price. You can do that. You shouldn't. I don't think React will complain. I'd have to double check in my console. I don't think it will complain. We'll check it out at the end here. React does provide a method called setState. So this .setState anywhere inside of the class or the component allows you to pass in an object with updated key pair values of values. So I want to change the price from 225 to 250. The reason you want to use setState is because that also fires off a bunch of other logic and a bunch of other updates. If you're expecting values on your components to update in real time, that's setState is how that happens. SetState fires off all the other lifecycle and lifetime events that need to fire. Props and state are those are both very important concepts in React. You really need to kind of understand these if nothing else. If you walk away with nothing else today, try to take this with you. Properties in React, that props object, data flows into a component. It's intended to pass values into components. Once into a component, it's read-only, and it's really useful for displaying and setting initial values. State then is always initialized in the constructor, and it's really intended to manage values inside of a component over the lifetime of a component. And you always want to make sure you use the setState method for updating state values over the lifetime of the method, lifetime of a component. All right, let's take a quick look at events. This is a whole other big one. I don't want you to try to have to learn it necessarily full scale, but at least recognize how it's done, and I think with relative ease anyway. So we have a component here called party. We have two methods, start party and end party. So we actually want our component to do something now. Here's our render method. So we have a couple of buttons we're rendering out. We're rendering out a button to start the party and a button to end the party. And we can use any common JavaScript method that you'd expect. So we can there's onclick, there's mouse, there's clicks, there's key ups, keys down, mouse over. All the usual JavaScript methods are available to us, and we can wire these up simply by saying this dot and reference our methods or our functions. This dot start party, this dot end party. React takes care of the rest of the wire up and bindings and all that. However, at least in this example, we do have to do some more boilerplate code we have to write. So in the constructor, we do have to do some binding, and this is strictly because of how this value works, this keyword works in JavaScript. So when you see class-based components in React like this, you're almost always going to see a bunch of boilerplate code at the top of a file in the constructor, just like this. Every event that you want to wire up in the render method does need to have this here. That's pretty much all I'll say about that for now. We'll see more of it in the example coming up. So React DOM.render, we're going to output this party component, and there you go. I can click on start this party, and I get the alert. Real quick, there are lifecycle methods available in React on components. So component did mount, for example, is called when a component is mounting to the DOM. A component will unmount is called as a component leaves the DOM. So if it's removed from the DOM, that method is called. There's a whole bunch of other component lifecycle methods available. I'm not going to go through them here. This is a crash course. I do encourage you to track them down on the documentation and learn all about them. We'll see an example here of the component did mount coming up as well. If I was to render this to the page, you'll notice that we get the alert, and oddly enough, I have an alert here, and it's console.log in the example, so that's a fun issue. You'll notice that it says component is mounting, and nothing's been rendered yet, so this does get called before the render method is executed. Fragments, and something that's probably not super critical to a crash course, but I've encountered them enough that I had to answer the question, what the heck are they? So in React, the React DOM.render method takes a parameter. It takes that first parameter as your content, right, your element. You'll notice that there's always a top-level parent tag there, in this case a div. If for some reason you don't want to render that top-level parent, you can actually use what's called a fragment, which is just an empty tag. This is valid JSX. This is valid code here. The difference being that if you don't want to mess up your markup, so let's say I have a div root 1, but I don't want this div right here, you can use a fragment to not render that div and just get down to the root. This is to ensure markup stays consistent, make sure markup stays clean, make sure you don't break any styling. So looking at what would be a sample application, this is an app, okay? So this app is actually a component, right? It extends React component. It has a constructor that does a bunch of work. I left that out. The render method then really just boils down to this. This should demonstrate that React applications are commonly a hierarchy of components. App is a component, header is a component, filters is a component, which probably has more components, subcomponents inside of it. There's a search results component here with some properties I'm passing in. There's a paging component that I'm again setting up some values here. Most React applications really boil down to a hierarchy of components, just like in Sitecore. Components really exist in a hierarchy of placeholders. This is central to React architecture here. You look at an interface and you break it down, you're really going to figure out what component lives where and under what other components. A few other things to learn that I did not cover in those slides there. Lifting state is an important concept. So I said that components maintain their own state. Other components are not supposed to be aware of other component state. So component A and component B that live next to each other, they'll never know what their state is. Component B that lives under component A will never know of each other's state either. Lifting state is a way of bringing that state from component B back up to component A so you can start to see some interoperability there. Component refs are a way of referencing components directly in code and manipulating them. We'll see an example of that here in a minute, but we're not going to spend a lot of time on it. HTML attributes in JSX is a little weird. So if you want to write, let's say you want to add a CSS class to a div, for example, typically you write div class equals something. Can't do that. JSX is closer to JavaScript than HTML. So there's a few quirks there you have to kind of learn. If you wanted to add a class to a div with JSX, you'd actually write you write div class name equals. Same with inline styles. There's all kinds of weird quirks there. I recommend looking up how HTML attributes work in React. Hooks is something worth looking into. This is definitely newer to React. Hooks were introduced with React 16. And it's basically a way of simplifying everything you just saw today. Hooks allow you to use the features of a class-based component in a function, along with a bunch of other cool stuff. But I'm not going to cover that here. That's definitely something that you guys can explore on your own. What I do want to do real quick, though, is see if I've learned anything, see if you've learned anything. Looking back at that Next.js example, we'll realize that going down this line by line, we see that we're importing something. So we're bringing some kind of module in here. It's React. Spoiler alert. We have class page extends React.component. So right now, I now know that this is actually a React component at this point. A bunch of this stuff is modern JavaScript, so I'm fetching some data. It's JSON, so it's spitting back a JSON object, and it's assigning that to something here. Okay, that's great. This is actually specific to Next.js here. And then here's our render method that React is expecting on our class, and here's our JSX. Here's our markup that we're returning. We are returning some properties. And then we're exporting this. So we're exporting this as a module so that something else can consume this page component. So this is a little easier for me to read nowadays. I feel a little bit better about it. I threw a lot at you at once. I don't expect you to necessarily have all that stick right away, but I'm hoping that by seeing these slides and seeing some of these concepts, next time you encounter these in the wild or you start reading documentation, you'll be like, oh yeah, okay, I get that. I remember seeing that. So in review, React is a library for building components. React DOM.render is always your entry point to start getting content onto the page. Between JSX or JavaScript, JSX is way more common. You saw it all through this presentation. That was where we mixed markup with JavaScript. A very clean way of writing markup in code. JSS components, class components, always extend that React.component class. So make sure you always do that when you're writing components as classes. And then definitely learn about properties versus state. That's very important concept in React. I want to make sure that the difference between those two things are clear. So real quick, I have about a minute left, so on my clock anyway. So what I want to do is flip over to an actual little demo application. And
don't rush out. Don't rush out.
I can slow it down. Don't worry. Let's spend a little time here then. So here's an actual application that I wrote to demo some of these concepts, and everything in this code base basically reflects the presentation. So we're going to spend some time going through that. So on the left, actually, let's not use DevTools. So on the left here, you'll see my browser. Oh, Sitecore links, get out of here. You'll see an app. I have a title. I have some filters. I have a little button here. It does something. Then I have a bunch of components. So this is all a list of hiking trails in North Georgia that I like to go on. It works. So I'm going to type in mountain here. I get Cow Rock Mountain. I can type in rock. I get Preacher's Rock. The clear button works. I can filter by difficulty. Okay, I can clear filters again. So when you look at this interface, you see that this is clearly a bunch of components, especially down here, right? This is a component is meant to be reused, usually, or used in a way that's easy and obvious, and that's what we're doing here. Flipping over to my markup then, this is the page that you see here. In fact, no, there's no better demonstration of why you don't send down React-driven content websites, because on my right is my source code and on my left is the HTML a browser sees. Google would absolutely crap itself over this. It has no idea what to do with it. They kind of do. They say they do. They think they can execute JavaScript, but it's just not as good as it could be. So the actual React application is pretty complex for search engines. We have a bunch of stuff at the top here. This is just everything I need to kind of get off the ground, some fonts, some styling, all of the scripts that I talked about earlier, React and Babel. Here's the root of the application. So this is where things get kicked off. And then down here, you'll see I've included all the different scripts that basically represent our components. So I have a title component. I have a trail component. I have a couple of filters. Then I have an app. I'm going to start with this index.js because that's where the application really kicks off. There it is. There's our React DOM.render. This is the entry point and the only one for the entire application. So I'm rendering out this app component. So if I follow this backwards and I go to the app component itself, I'm at the bottom of it. Hopefully some of this is familiar at this point, and if that's too small, let me know. I've been talking like I'm presenting on a white projector for the last 2 years, and everyone's on their screen, so I'm assuming everyone can read it, but.
It's okay.
Perfect, thanks. So we have an app, it's a React component. We have a constructor where we initialize some data. There's some of our boilerplate code that I talked about as far as wiring up events and references. Here's one of our lifecycle methods right here, component did mount. And in this, we are going off and getting our trail data. It's actually a JSON object, so it should be familiar there. We're setting state right away, so we set state with that data. We set it to some internal variables that we actually established up here in our constructor. And then we provide a bunch of functionality, what happens when things change, what happens when filters get updated, stuff like that. The really key thing to take away here is the render method. So we get down to the render method here, and we're returning the rest of the application. So here's a fragment, because we just want to have an empty fragment to start with. And then we have a bunch of components. We have our title component. There's our text that we're outputting. We have our filters, our type ahead filter, our rating filter with our radio buttons. We have a button here, which I'm wiring up manually to reset filters. And then we have a list of trail components. I'm using a JavaScript method, an array method called map to iterate over the data. And I'm outputting a trail component for each one of those. So for each one of the data items that comes in here, I am passing those in as properties to each component. So if I come to the trail then, this will be the last one we look at, here's the trail component that represents each one of these little cards right here. So we have a title, an H3, we have our image, and then we have all the attributes below that, along with a little bit of logic to decorate it, clean it up. We do a little conversion of our math here to make sure we have the right kilometers and mileage and all that for the length. And that's pretty much it. This is, so going back to, I think that if you're gonna look at this app yourself, I highly recommend you spend time looking at the app.js component, because this is where the rest of the page kind of comes together, and you see the structure really come together here in this render method. The rest of these components, like the type ahead, they're all pretty much the same thing. They have a constructor that sets some initial values up, and they provide some functionality, and then they render out all the markup that they need to function. This code here, if you're interested, I do have on my GitHub, so you can actually go through this very same example here. I tried to write this to be, I wanted this to match the general feeling and level of the presentation itself. So even though I went through things pretty quick, I think you could probably go through this app and kind of study some of the concepts here. The live demo link is here. I have a few other resources I kind of used on and off here. And that's it. I mean, I encourage you guys to check this out. I can make the presentation available on the same repo if you want the PDF of that, so you can kind of go through it as well. But that is actually it for me. So thank you. Any questions, comments?
I was on mute here.
You guys going to say
thanks, Brennan.
Yep.
Yeah, thanks, Brennan. Now, that was an amazing presentation. I think it will be very important to have this in the SUG-BR channel. A great addition to our library. I have only good things to say about this, and your style I think was very appropriated for us to follow. I was hooked from the beginning to the end. I have some questions here. People are typing. First, about the SEO, the issues with the SEO, right? You mentioned you have a slide for that about the way you render and about the way that robots will be able to see your page, right? Can you elaborate more about what the extra work you have for, having a traditional, your application look for the robots as a traditional application when you have like a single page application like that you're showing, right?
Yeah, so let me make sure I understand the question right. So you're asking the differences, like how does what I'm showing compare to maybe like content versus a SPA single page app?
Yeah, because I think you mentioned twice in the presentation in the beginning, and then you have a slide only dedicated to show, how a page looks for the robot, for the browser, right?
Oh,
so
yeah.
What does that mean to the implementation in the end? What is the extra work for the SEO to be respected?
Oh, yeah. I mean, yeah, okay. So let me answer that in two ways. So one, I want to make sure everyone's clear that when a page is rendered by the browser, right? If you send down a blank HTML page with a bunch of JavaScript, and the JavaScript goes off and pulls in content and builds the page, what's that mean? That means the client's doing all the work, right? And that means that our search engines have to do the same work, and that is a problem, right? Because search engines have to index billions and billions of items per week or per day or what. I don't even know how many they do, honestly, and they just can't do that same work, right? And there was a really good. Did anyone go to there's a presentation at Symposium. Render. The render is all about rendering. Render there, render here, render everywhere. I think it was called. That presentation covers this concept very well. If you can't, you don't want the client to be responsible for rendering a content-driven page. The extra work then comes back to us as developers. It comes back to the servers. It comes back. Somehow you need to present a complete page with the content you actually care about for SEO purposes to the internet. That's what it comes down to. Doing that can be a lot of work, and the workload varies depending on your approach. If you want to write a React application, you're talking about rendering React on the server-side generation, right? Server-side rendering. You could also talk about static site generation, where you pre-render all of your React applications. As a traditional backend guy, I think what we've done is basically come full circle here, where we've started to explore the exciting things we can do on the front end, and then we realized that maybe doing these things on the front end isn't the best thing for performance and isn't the best thing for SEO, and oh crap, we need to get the server involved anyway. And And that's really what it boils down to. If you can write a React application and you can serve it to the client, but in the long run, you still have to serve HTML to a browser, and that's the best way to go. And rendering these things on the server is something we're having to explore in the last 5-6 years and going forward. Static site generation is really exciting. That seems like the future. We'll see what happens.
What about detection, right? Because you can detect that Google or a search engine is what's crawling you and present them with more static content of what's important for that type of page that you actually want to get your SEO on, as opposed to your rendering. I know you get, sometimes Google will penalize you if it realizes you're doing something different, but what about doing something similar like that, where you can go, okay, you're a search engine, this
like
is what you're
metadata, like metadata. Yeah.
Do we trust that robot detection to be accurate though? I mean, we have to at some point, but like, I mean, anybody can send anything they want across the wire as far as a refer or a robot. So yeah, we could do that. You're right. That's one solution. As long as you don't mind throwing all that same data at garbage bots and junk and anything else that might be out there. The internet's a dangerous place.
Yeah. In the beginning, you mentioned that that mix of HTML and JavaScript and business logic and markup, that was against the way you learned JavaScript, right? Can you just elaborate a little more about that? Why it's against?
Well, I specifically referring to JSX. So the idea that the idea that you write JavaScript and markup in the same place is so foreign to me. I learned, and my background was, the first time I ever wrote code was long time ago. I'm very a big fan of statically typed languages. JavaScript took forever for me to learn, and when we start throwing markup in there, I'm like, that's not valid. I know that's not valid. Those should be strings. Dang it! Don't screw with me like this. Yeah, that was my biggest problem, was mixing everything together. And that's what you see in a lot of these common frameworks. And JSX does that, right? Allows you to write JavaScript or what looks like JavaScript and mix in markup, and it meshes two worlds together. And the benefits really are for the developer. It's just that. So it's a different paradigm. It's something I have to get used to. I'm doing my best not to be stuck in my old ways, right?
Yeah, I think it makes sense if you think about that as a presentation logic, right? So you mix both, like for the dinosaurs, like Razzle and things like that. And when it comes to the presentation, right, you have to render a lot of things, and from Sitecore into the front end, and Sitecore has multiple field types. You have images, you have string types, you have I don't know, a lot of different types. So in MVC, Sitecore had, and for those that are older, even previous to that, you have the web forms. Yes. So you used to have a lot of help, right, from Sitecore, the API and the framework to render things easily. How does that goes with JSS? With Razor in this case.
Yeah. So I mean, I'm not going to talk about JSS specifically because I'm still coming up to speed on that. I mean, ultimately, remember what the Sitecore layout service is returning to you is JSON. It's giving you a bunch of JSON essentially, and it's giving you what you need to populate these components is what it comes down to. So hey, here's the image in a placeholder with this value. Here's the path to it. Let your use it in your component. Where if you're going to build a component that needs an image, what's your source? What's your alt tag? That's what you're getting back from Sitecore. That's what you're really building with.
Great. Okay. Anything else, guys? Please drop in the chat window. That was amazing, Brandon. I have no words. That was a lot of knowledge condensed in these few 45 minutes.
I have a question.
Yes.
Is there? I mean, this is only the second. Well, this is the third time I've given this. So help me out. I mean, that's the 45-minute version. I'm comfortable doing the hour-long version. What do you guys? What was too quick? What was too slow? Like, should I drop something? Is there anything you think I could? What can I take out to make the hour more comfortable? Nothing. Something.
From my side, I think the format is perfect. It would be interesting to allow some pauses to speak about the concepts as we go, even if it will inject more time in the final presentation, but because it takes time to digest, right? Especially
it does, yeah. No time to pause. I think that's something I want to do is I like diagrams and pictures as well, so I'm working to find a way to fit those in there, so we'll see what happens.
Yeah, this is definitely very promising. Okay, I think we're done. Thank you very much, Brandon. It was amazing.
Thank you. Great crowd.
And that was the end of the November. I don't know. We're October edition. Yeah, it's crazy.
Don't do that to me. It's only October, man. Don't do that.
Time is passing so fast. Yes. And stay with us. Kiptan, Sitecore User Group Brazil will always get back to you if you like or not. Thank you very much. Thanks, guys.
Thank you.
Thank you.
Thanks, Eduardo. Night. Thanks, Brandon. Thanks, Chris. Yep. And all the participations. Thanks, Ragnar, Prasad. People from Asia are here. Deolan, Alvaro, Felipe, Eduardo. Thanks all. Bye.